I'm going to be talking about my master's dissertation research, which I finished up last fall, and also a bit of work I've been doing since then because we got a new data set related to the work I was doing. And so I've been working with that a bit. Um, anyway, my research recently has been using bathymetric data sets to update and improve the rec record of the Goodwin Sands, which, oops, that's a quick clicking button. Okay. The Goodwin Sands is a pair of sandbanks off the Deal Coast in the UK. It's very historically relevant, such so much so that it's been referenced in a number of works of literature, as are quoted on the board. It is very well known for wrecking lots of ships, partly due to one sec, uh, kind of due to a combination of its location because it's sort of centrally located along a lot of different maritime trade routes, and also the fact that since it's a giant mass of unconsolidated sand, it has a tendency to shift due to the tidal influences of the water around it. Um, the geomorphology of the area is really fascinating, and if you're interested in that, you should definitely come talk to me later. But what I'm trying to focus on here is the shipwreck specifically. And one point that I will point out here is Calamity Corner, which is very interestingly named, and we'll talk about in a little bit. But it's the place that I've been focusing a lot of my research because it has a lot of shipwrecks that are well exposed and things that you can see on bathymetric data. So bathymetric data, for anybody, why does this keep doing that? Sorry. Bathymetric data is, for anybody who's not familiar with ocean research, is basically like a topographic map of the seabed. And uh, it generally will either come as a 3D point cloud or as a raster image that's basically taken the 3D point cloud and binned it into a bunch of pixels, which is what I was working with for my original dissertation research. And we actually got access to the original point cloud data for one of the data sets I was working with, but it was too late to include it in my dissertation research, but that's what I've been working with since then. Reasons that bathymetric data is useful in maritime archaeology is that its broad scale allows a much wider search area than you would get if you were trying to individually look at every site. This can be useful both for kind of getting a broad picture of a wreck that you know is there, and also for searching for other wrecks that might be in the area that you didn't know about already. The fine resolution that you can get from bathymetric data allows pretty decent analysis of wrecks without having to go through any on-site work. And often bathymetric data sets are already available because they're super useful for navigational safety and other projects that might involve construction in the ocean and things like that. So these kinds of data sets are out there for a lot of places if you look for them. The data sets I was using specifically, this keeps happening. The data sets I was using, there were three consecutive data sets from the UKHO, which is the United Kingdom Hydrography Office. They, as is kind of needed in the Goodwin Sands, take regular bathymetric surveys to kind of see how the sands is changing so that they can update their navigational safety charts and records and things like that. And then I also had another survey that was taken for the UK Department of Environment, Food and Rural Affairs. I wasn't able to find a whole lot of information about why that survey was taken, but it was available through the UKHO's Inspire website, which there's a link for up there. And basically the UKHO is really awesome and puts most of their data sets up online, or at least kind of binned versions of them. We sent off to the UKHO to get the original point cloud data set, which is what I've been working with recently. As for the shipwreck data set things, we used several different data sets of information about historical shipwrecks in the Goodwin Sands. And basically the data sets had kind of information about what the ships were, what, lengths and widths and things like that. It kind of depended on the wreck how much information we had, but a few of them I had enough information to kind of compare them with my bathymetric data sets and say fairly definitively, yes, this is this wreck, so that we could confirm those locations. So my data processing, I used Esri ArcMap for all of my analysis, but there are also similar products that are free to use, open source, things like that. QGIS is one of the ones that I know of, which is a point that I'll be making throughout the talk, is that basically everything that I've been doing is something that can be done in a lot of places when the data is available, basically for free, because the data has already been collected, and there are a lot of open source and free software that you can use for this stuff. Anyway, so I created slope maps, hillshades, and curvature maps for each of my bathymetry data sets. The slope map kind of gives you a good sense of kind of where the edges of the shipwreck are, because it sticks up really well from the rest of the surrounding seabed. The hillshade kind of those three gives the best kind of realistic view of what the ship looks like, because it's kind of as if you were shining light on it, so you're kind of seeing a shaded image of it. And then the curvature kind of gives you a better idea of areas where there's a lot of change vertically in the wreck. So like you can see several little points on the lower bit there that it's kind of going up and down in the center of the wreck piece. And then for making pretty images of things, I layered the hillshade underneath the original data set to give kind of a composite look that sort of looks sort of like a real wreck, and also, gives you some amount of useful data about what the wreck looks like. So my first step in analyzing the wrecks was ignoring all of my shipwreck data sets and just looking at the bathymetry to make sure that I was getting an unbiased view and didn't, have any preconceptions about what might or might not be a wreck. And those are shown in little red dots. And then I compared it afterwards to the different shipwrecks that I knew to exist in the area. And for the most part, a lot of them kind of were one-to-one, or else there were some things that I wasn't sure if were wrecks, but I listed anyway, and then they didn't turn out to have wrecks associated with them, but it's all good. But there were a few instances where the historic record and the bathymetric data didn't line up in ways that I thought were interesting and were potentially areas where I could update and improve our knowledge of the area. Specifically, there were the Calamity Corner wrecks, which, as I said, we'd get back to. There were the three wrecks here, here, and here, two of which were labeled as the SS Ira and the Luray Victory, and the third of which didn't have a label. And there is also the wreck over here, which I've associated with the Valsalis, which we'll get to in a minute. But really quick aside on Calamity Corner, because it's a fascinating area. It got the nickname during World War II because a lot of wrecks, including the ones that are over here, sunk during that time period. And it just, there were so many wrecks that sunk during that time period that they had to nickname it because because it was rather significant. Anyway, so the Valsalis, in the historic record, the location that's given is listed as for filing purposes only, because they didn't really know exactly where the wreck went down. It sunk during a major storm in 1916, and no one really knew exactly where the wreck had gone to, or where it had gone down exactly. So I took some measurements of the wreck that I found over here, and the beam length and the length of the vessel match up nearly exactly with the recorded length and beam for the Valsalis. So I think that it's the correct wreck, but there's not really much more that I can say about that at the moment. because it's in this image mostly buried, and this was the earliest of the 3 surveys that I had, and in the later ones it's still sort of visible, but it's very quickly covering over. As for the other 3 wrecks, Rec 45, which is this pair of wrecks, because I'm imaging them separately, but they're basically next to each other. Rec 45 was previously unidentified. Rec 46 had been labeled the Lady Victory, and Rec 48 had been labeled as the SS Ira. And based on the length and beam measurements, I figured out that it looks like if you combine those 2 wrecks, they match up and match the length and beam for the Lore Victory, and similarly, these pieces, if you add up all of the lengths, match the SS Ira. So that's about as far as I was able to get with GIS, with the binned raster data, saying, yeah, the lengths and the widths match, and there are a couple of, maybe defining features, like this looks like it might be a mast or a cargo winch or something like that. But then we looked at the point cloud data, and the point cloud data is much prettier. You can very clearly see a lot of things on that you couldn't see just from the binned raster data. So for processing the point cloud data, it took me a while to find a piece of software that did it, because at the point when I was trying to process it, I was no longer a student at the University of Southampton, which is where I did my master's degree. And so I didn't have access to the proprietary software that they had for doing this sort of stuff. But I found a really cool program called Pure File Magic, which is a great name, by the way. Pure File Magic Area-Based Editor, which was and is still being developed by the U.S. Naval Oceanographic Office for processing and analyzing sonar and LiDAR data. It supports a lot of different file types, including GSF or general sensor format files, which is what I was working with, and it's available for download from their handy website here. Pure File Magic is a fairly straightforward list of steps that you go through to get your data from kind of the format that it comes out of the sensors as into something that can be read by most other 3D point cloud software. The file edit 3D, which I didn't end up using because the data I was looking at had already been dejunked in a sense, basically allows you to edit your point cloud before you put it through into whatever other file types you want to put it into, so that you can get rid of any outliers or things that just look like noise and not good data. The trackline function, and these are kind of just going sequentially along the buttons there. Trackline creates a minimum bounding rectangle, which shows you just kind of what the area of the individual tracklines are. And tracklines are kind of the way that you collect bathymetry data is you take a boat and you go back and forth, and each line that you take is a trackline. And so you get a bunch of different track lines that you then need to put into either the software or other software to make into one single point cloud. Area check allows you to compare the individual bounding rectangles with the relevant areas where you think the wrecks are going to be. So it's useful to have both the GIS or binned data so you can look at that and figure out what areas you want to focus on before going into this software to make your 3D point cloud pretty. After you have an idea of what track lines you want to load, you then use PFM load to load the trackline data. And in that step, it gives you the option of selecting an area that you want to only look at data from that area. And so it will look through all of the data and all of the track lines that you give it, but it'll only take out the points that are in the area that you tell it to look at. PFM view then gives you this kind of a view setup and lets you look at the data that you've put into, or the data that you've loaded into your Pure File Magic file, which again is a great name. And then from there, you can extract it to a variety of file formats. And if you wanted to take it from here into GIS type software, you can make it a georeference TIFF image. So from there, I took the data, or I exported the data as an ASCII XYZ file so that I could open it in Cloud Compare, which is a 3D point cloud editing software that I'm more familiar with. It allows you to, clip the point clouds, and so that you're only looking at the relevant areas when you're trying to visualize it. It has kind of the ability to create viewports and videos and all kinds of stuff, so that you can like make really nice, pretty images with your videos with your data, and the handy color by height function, which I use to make it actually look like a shipwreck instead of a giant green blob. So with this, we were able to get a much better comparison to historic photographs and other things of the wrecks. So on this you can see there's rather obviously the helicopter pad and this mast that I think might be a cargo winch. I forget exactly what it was. And then there's these two bits that are sticking up that I wasn't able to figure out what those were called, but they are fairly obvious over there. And even more fun, it spins. It's a little fuzzy for some reason. It looked better on my computer than it does now, but again, you can see the two posts and some of the other features I was talking about. And it makes really pretty spinny models. I like 3D spinning models, they're very fun. But it similarly, the SSIRA has a similar level of visual detail. You can see a cargo hatch and a couple of potentially cargo winches. And one thing that this was the first of the different models that I brought up, and I was just kind of amazed by the fact that you can see the individual posts on the railing on the side of the ship, which just kind of blew my mind, because this is data that wasn't even taken for archaeological purposes, and we're still able to get this level of detail. And you can also see the rudder in the corner and the propeller of the ship, and just there's a lot of good stuff there. And again, we have pretty spinny models that show, and you can see there's a bulkhead kind of in the underneath there, which is probably why that part is still being held up. One thing that I haven't done yet that I think would be interesting to do, especially for ships that have pretty good historical records of the dimensions of the ship and like specific parts of the ship, is another feature that Cloud Compare has, is being able to measure between 2 points on a model. So I could literally go in and compare, okay, is this the same distance as it is on the historical record of what the ship should look like? Unfortunately, the Valsalis model didn't really turn out quite as well. This is the 2015, which is the most recent of the surveys. And the model gives a little bit more data, but it still kind of just mostly looks like it's been buried, which is what's happening to the ship. So that's one downside of this method, is that it only really can work on ships that are uncovered and exposed, because if they're not exposed, then you're just going to see seabed. And and basically for wrecks like this, you're not getting a whole lot more out of the point cloud than you would if you were just using the GIS model, because there's not really much more information that you're going to get out of it. One of the next steps I'm looking at is trying to make mesh models out of my point clouds. I haven't gotten very far with this yet, but my first couple of attempts have been a little bit iffy, because it turns out the way that you get a point cloud from swath bathymetry data is it basically goes and at every time step like takes a fan ping out, and so there's a different distance between points in one direction than in the other direction. And so when you're doing nearest neighbor type calculations, it screws it up a bit and is kind of hard to create a 3D model from that. But I'm still working on it, so fingers crossed with that. So anyway, specific things that I've managed to do with this project were correcting the identification of the SSIRA wreckage and recognizing both of the fragments of the Luray Victory, which are currently somewhat separated, and also to suggest a possible location for the Valsalis wreck. And then more in general, this methodology could be used in other areas for similar situations where you have shipwrecks that you would like to have more data about, but don't have the funds or the ability to do field work on the actual site. So, if if anyone has questions. In the back?
What's the depth?
Hmm?
What is the depth you're talking about?
It really depends. The Goodwin Sands has one of the largest tidal ranges in the world, and so the depths that you're looking at are at high tide between like 10 to 20 or so meters, and then at low tide, some of it is like not actually underwater anymore. So yeah, that's kind of the tide range you're looking at there. Um, I don't know about other places, but that is what you're looking at the Goodwin Sands.
What was the earliest ships that you could see this way, and how did they differ in materials?
So the ships that I was able to see on my data were mostly World War II, World War One, World War II wrecks. They are mostly all made of metal at that point, but there are a few wrecks that have been studied more extensively already because they were, exciting and interesting when they were found, that were from the early 1700s. So those were wooden shipwrecks. And I was able to see like one or two of those on my data, but most of them are kind of, the longer they're there, they sink into the sands, which just the mass of sand can be up to like 80 feet deep at its deepest. So a lot of the wrecks that have been there for a while are just going to be under there somewhere, but hard to actually see. Yes?
So as the sands move, are new wrecks being exposed, and how frequently, forgive me if you already said this, but how frequently are the surveys made?
I had it in my notes, but I think I forgot to actually say it. The 3 surveys that I had were from 2009, 2012, and 2015, so every 3 years-ish. I don't know if the UKHO is planning to continue doing 3-year survey spans, but they're fairly regular surveys of the area. Was there more to your question? I feel like there was another part, sorry.
Are wrecks being uncovered?
Yes. So there were maybe 1 or 2 wrecks that I saw that were significantly uncovered, but during the time period that I was looking at, they were already a little bit uncovered, so I already saw them on the first data set, but then they're becoming more uncovered. A lot of the wrecks that were fairly obvious wrecks tend to be in the areas that are becoming more covered, so it seems like there's more of a tendency currently for wrecks to be becoming covered than becoming uncovered. But again, that also has to do with the geomorphology, because if you're interested in the geomorphology, I can talk to you about the geomorphology, but I don't know. Yes?
You said at high tide that this is about 20 meters.
Yeah, it depends on where on the sands you are, because it can vary from like 5 to 10 meters at some of the higher areas to like 20 to 30 meters down, depending on where on the sandbank you are.
Do you know if you could get the same kind of results at a much more significant,
Um,
or have you thought about trying anything?
I haven't thought about doing things at a more significant depth, and I think that most swath bathymetry data sets tend to be kind of in that range of depths. I think that there are I think that there is technology that lets you get bathymetry readings of lower depths, but I haven't looked into it much. Yes?
What is the turbidity like in the Goodwin Sands, and would that affect the data that you're getting?
I have not looked into the turbidity a whole lot. I mostly just trusted that the UKHO's surveys were pretty reasonable.
I was wondering if this same kind of thing could be used in like the Mississippi River,
I suspect so, given that what I have seen of the Goodwin Sands is that it's a really, really poor place to go diving, because it's got just, you can't see anything because of the massive tidal range. There's always like sediment everywhere. So I would suspect it's possible, but it'd probably be somewhat noisy data, and as with mine, you'd probably have to do some editing to the data, but it was done before I got a hold of it, so I don't have as much experience with that. Yep.
What is the technology? Is it LiDAR, or is it something different?
The ones that I'm using,
The
or
bathymetry, is it?
yeah, it's multi-beam sonar data. So yeah, basically you have a towfish behind the boat that knows its location and then pings out fans of sonar pings. Is that any other questions?
Any other questions?